Hello. So for this algorithm example, what we're looking at is thinking about the design and analysis phase of problem solving. And this is the foundation before any coding takes place. You really want to think about not just solving a problem, but the most efficient way to solve a problem where the computer is doing the least amount of work, it's taking the least amount of resources. You don't want to make a program that's a memory hog. So when there's more than one way to solve a problem, think through and find the most efficient way possible. And that's what makes a really good programmer. So here is an example problem. We're going to sum the numbers 1 through 100. So just 1 plus 2 plus 3 all the way up to 100. So method 1, this is going to be the simplest way to do that, is just to have a column of numbers, add them all together. There we go, 50-50. Thinking about this, and it was a pretty neat person who came up with the idea of how to do this, a different method. So they looked at it and said, well, let's add up pairs of numbers. So we're going to look at the very first one, 1, and the last one, 100. 1 plus 100. And then we'll go to another pair of numbers, 2 and 99. And then 3 and 98. So if you look at all those pairs, and for 100 numbers, there would be 50 pairs of those. Each of these pairs is designed to add to the same value. So 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is 101. So method 2 is kind of a different way to get to the end result. It has a lot more computations involved. We have all of these individual additions, and then we have this extra row of data, and we're adding all these extra numbers together. But the end result, you can see, is the same. And we're going to do this in Excel, so we can see this 50-50 in Excel too. Method 2 is a lot more time intensive and a lot more calculations. But the thought process here is what's important, because method 2 is what allows us to jump into method 3, where we now have a nice and tidy little equation. So this equation, if you think about how I could put this method 2 into equation, so I'm adding together 100 numbers, 1 to 100, and if I add them in pairs, then I have 100 divided by 2. I have 50 pairs of numbers that I'm adding together here. So that's the first part of this equation, n over 2. I have 50 pairs. And each of these pairs is adding to the same number. And so what I'm doing is I'm multiplying 50 times whatever that pair adds together as. So here's an equation. And method 3 is so much more efficient than method 1. So we no longer need a list of numbers 1 to 100. So there's no data that needs to be stored. It's done with one calculation. And method 3 has the added advantage that I can set this up to take in multiple scenarios. So instead of just 1 to 100, does it work for 100 to 200, 50 to 250? So I can put different scenarios very easily in here too without having to create new data sets. And so for a few different programs, I'll have you post what you create in the discussion forum and then reply to somebody else's post and think through different ways to accomplish the same task, and then analyze those methods to finally decide which one is going to be most efficient. Okay, so let's go ahead and put method 1, 2, and 3 into Excel. And again, this isn't too hard of a problem. The point of this is a thought experiment and realizing that there's always going to be more than one way to solve any problem, and there's going to be a more efficient way. So I'm going to go ahead and copy some notes into just a brand new Excel file, and we can go ahead and set this up. So I'll have one here for method 1, and it's good to add comments to whatever you're doing. So if I have a column, I can say this is column 1 to 100. I made that arrow with Alt and 248. That's the shortcut for making that arrow. Learning a few of those shortcuts can come in handy. So first, let's go ahead and make a column of 1 to 100. So 1, 2, 3. If you start a pattern, you can then grab this and pull it down, and it'll keep that pattern going for you. So that's one of the nice features in Excel, is it'll do a lot of things for you if you just start the pattern. Okay, so there is our 1 to 100 column, and then we want another column, sum 1 to 100. So we want to add all these together. So I'm just going to say equals sum. So we'll use, and each programming package, most of them at least, have libraries with little functions in here. So if you want to add numbers, multiply numbers, there's going to be a library, and you just have to dig in and use the functions that are already there for you. So that saves a lot of programming time too. Okay, so there's that same 50-50 number that was given in the example. So there's method 1. Let's just do a little bit of formatting here. So here's our merge and center. We can throw on a border, make it bold. And here's our headers on here. To resize a column, I can just double click, and that will automatically resize it to perfectly fit the largest value in here. And remember, if I want to change my number format, that's going to be over here. Okay, there's method number 1. Let's go ahead and try out method 2. And as you're putting this in, think about how many calculations the computer has to do, how much data it has to store. So for this one, it looks like I have one column going from 1 to 50. Let's call this column A. So this is going to go from 1 to 50. And then I'll have another column B. And this is going to go from 100 to 51. So we're splitting this big column of numbers into just 2 chunks. So instead of 1 plus 2, it's going to be 1 plus 100. And then it will be 2 plus 99. And we're splitting it up like that because these guys add together to 101. All of these pairs are going to be adding together to the same number. So that's kind of a neat thing. Okay, if I start this pattern, I can go ahead and grab all 3 rows at once, and I'll pull this down to 50. I'm using that first column over there to see how much to come it down. So here's the first half of the column, 1 to 50, 51, 52. So all in all, I'm adding together all of those numbers. I'm just seeing this kind of neat pattern that if I break it up, A plus B. So here's my columns. And then at the very end, so this is my A plus B column. I should get that same number out of there. So I'll go ahead and add up all of these 101s. And sure enough, there's that 50-50 again. Okay, so that is method number 2. So we have 2 columns worth of data. So far, 2 columns versus 1 column. I still have 100 numbers that I'm storing. But this little column here, where I'm doing all of these little individual additions, this is starting to make the computer do a few more calculations than what it did for number 1. So I just had one summation for method 1 versus now I have all these extra calculations. And then I'm also using the sum function. So method 2 is quite a bit more of a memory hog than method number 1 is, but it was valuable in that it taught us what we need to know to understand this equation that is over here for method number 3. Okay, so last one, let's set up method number 3. The other thing to think through for all of this is what are the inputs to the program? So inputs, this is what you have to tell the computer. So in this case, we have to tell the computer the number of terms that we want to add and what our first number is going to be. So in this case, 1, up to the last number that we're going to have. We could maybe even get away with getting rid of that n in here. So here's our inputs. We can have that all organized over here. And from those inputs, we are then going to have an output, which is the sum of these numbers. So whatever number A is all the way through B is, we're going to add those all together. So here is our output. And we'll go ahead, set a table up. It really does help to organize your thoughts and the problems to have a nicely formatted interface for you. That's the best programming languages have really nice compilers that are back from when I first started programming to how it is now. The compilers are so much nicer and cleaner for a user interface. So yeah, what it looks like really is important. It'll make users much, much happier if your information is organized in a nice, clean manner. Okay, so for our n, we're adding together 100 numbers, and our first number is 1, and our last number is 100. And so we're going to put this equation in. So we're adding together 50 pairs. So that would be our n divided by 2. So there's our 50 pairs. And each of those pairs adds up to 101, A plus B. So that's each of those little pairs. Okay, so in this case, our number n is cell K6. Our number A is K7, and B is K8. And yay, we have 50-50 again, so we can go ahead and one more thing, let me show you. So I actually can enter this equation with n, a, b, with however I define the variables, and sometimes it's easier to keep track of things instead of keeping things with a cell number. So let me just scooch over here and zoom in. So over here on the upper left-hand side, you'll see it tells me that this is K6. I can actually highlight this and rename that cell. So I'm going to rename this cell, and I can't call it N5 or something that would conflict with another cell that's there, but I can rename that cell. So I'm going to rename all of these cells. So here K7, I'm renaming with A. And then K8, I'll just highlight K8, and I'm going to rename that B. So you just type it and then hit enter, and that will help you rename it. And what that allows us to do is in our equation here, I can then actually type the equation in just like it is in the note. So I can call this N, and I can call this A, and I can call this B. So that's a little bit nicer of a code if we have variable names that relate to something that we recognize a little bit more. So another little trick there. Okay, so there is the first example. So we have the same problem solved 3 different ways, and and you can see how much more efficient this method 3 is. So method 3 is the winner, yay, versus method 1. And it really does pay to spend some time thinking through all the different ways you can solve a problem and then settling on the most efficient way in the end. Okay, thanks for listening.